Every single time you load a web page, or send an email, or stream a show, you're tapping into this powerful, totally invisible language. So today, we're going to make that language visible. We are diving into protocols, the basic rules that honestly make our entire digital world possible.
All right, let's just jump right in with a question that you've probably never even thought to ask. How in the world can your Apple iPhone send an email and it just shows up looking perfect on your friend's Android phone? I mean, think about it. They're made by completely different companies, running totally different software. How does that actually work?
Well, the answer is surprisingly simple, and it's the key to this whole conversation. It works because of something called a protocol. That's it. A protocol is just a standard set of rules that all these different devices agree to follow so they can talk to each other. It's like the universal translator for all our technology.
To really wrap our heads around this, let's step away from the tech for a second and start with a simple human analogy, something like a handshake.
Yeah, this idea of a shared language is really the perfect way to look at it. Just like two people need to speak a common language to have a real conversation, devices need a common protocol to communicate. It doesn't matter who made them or what software they're running.
So let's break that down a bit more. In a human conversation, right, we have these unwritten rules, this etiquette, like shaking hands when you meet someone. In the digital world, that's the protocol. We use a shared vocabulary to be understood. Devices use common data formats. And we might nod our heads to show we're listening. Well, devices send back confirmation messages to check for errors. It's basically a very, very structured conversation.
Okay, so if protocols are the rules of the game, what exactly are they controlling? Let's get into the nitty-gritty of how these rules actually create a successful digital conversation. Just think about it for a second. If you were the one designing a system for two computers to talk to each other, what's the first information you would absolutely have to figure out?
It really just comes down to these 4 essential jobs. First, you gotta identify who's sending and who's receiving. Simple enough. Second, you have to agree on a format, a common language. Third, you control the pace. Now this one is critical. Imagine a brand new, super fast server trying to send a ton of data to a 10-year-old phone. That server can fire off information way faster than the old phone can handle it. So the protocol acts like a traffic cop, managing the flow so the slower device doesn't get totally overwhelmed. And finally, number 4, you have to confirm that the message actually got there correctly, with no mistakes.
Now, to agree on that format we talked about, our messages have to be translated into a language that devices can physically send. That's where something called encoding comes in. It's the process of turning our data, text, pictures, whatever, into electrical pulses or light signals that can literally zip across cables or fly through the air.
The next step is a cool one called encapsulation. The best way to think about this is like putting your letter, that's your data, into a digital envelope. This process wraps your data with all the crucial info it needs for the journey. Things to identify the sender and receiver, and instructions to confirm it arrives safely. It's basically the address, the return address, and the postage all bundled together.
And here's where it gets really, really clever. It's not just one single protocol doing all this work. No, it's a whole team of them, all working together in this highly organized system.
See, a single device uses a whole group of protocols, which we call a protocol suite. Think of it less like a single rulebook and more like an entire library, or maybe like different departments in a company. Each protocol has a very specific job, and they all have to work together perfectly to get your data delivered. The most common team out there is the TCP/IP suite, and it works in 4 layers. Let's start at the very bottom with layer 1, the link layer. This is the physical stuff. Your Wi-Fi card, your Ethernet cable. Its only job is to move signals around. Moving up, we get to layer 2, the internet layer. This uses the famous Internet Protocol, or IP. Think of IP as a global GPS system. It stamps an address on your data so it knows where to go. Next up, layer 3, the transport layer, uses TCP. This chops your big message into smaller, numbered packets and then makes sure they all arrive in the right order with no errors. And finally, at the very top, layer 4 is the application layer. This has specific rules for whatever you're doing, like HTTP for browsing websites or IMAP for grabbing your email. Each layer does its job, then wraps the data and passes it down to the layer below.
Okay, so that's a lot of theory. Let's bring it back and connect all these dots directly to the things you actually do every single day online. Where do you see these protocols?
The thing is, you use them constantly. Every time you type in a web address, you're using HTTP, the Hypertext Transfer Protocol. Firing off an email,
That's SMTP, the Simple Mail Transfer Protocol. Even just connecting to your Wi-Fi is governed by a protocol, probably one from the 802.11 family. And under all of that, the Internet Protocol, IP, is working away making sure every single packet gets to the right address anywhere in the world.
And the real magic here is that this incredibly complex stack of rules, with all these different layers and jobs, all works together so flawlessly that we don't even notice it's happening. It all just works.
So if there's one thing to take away, it's this. Protocols are the silent, invisible language of our digital age. They are the shared rules that let a whole world of different devices, made by thousands of competing companies, speak to each other fluently, connecting all of us in one massive global network.
And that kind of leaves us with a final thought to chew on. As we keep connecting everything, from our cars, to our refrigerators, to the internet, what new challenges are we going to face? What new rules of communication? What new protocols are we going to have to invent for the future?